Here's a blunt truth. If you don't understand RCC design, you're not a civil engineer, you're a bystander. Because every building, every bridge, every foundation begins with one question. Can this structure safely carry the load? Today, I'll break RCC into its simplest, most practical form. Number one, what RCC actually means. Reinforced cement concrete equals concrete plus steel, working as a team. Concrete handles compression, steel handles tension. This combo is why RCC dominates modern construction. It's strong, durable, economical, and easy to shape. 2. The four core RCC elements. These four decide whether your structure stands or fails. No exaggeration. A. Slabs, the load spreaders. Slabs distribute loads to beams and columns. Key points. One-way slabs, supported on two opposite sides. Two-way slabs, supported on all four sides. Main reinforcement runs in the direction of maximum bending. Real-world impact. Bad slab design equals excessive deflection, cracked ceilings, complaints for years. Every building you enter depends on correct slab thickness plus steel layout. B. Beams, the bending warriors. Beams carry loads from slabs and pass them to columns. Key points. Tension steel at the bottom, sagging. Compression zone on top, stirrups handle shear, not flexure. Beam depth controls bending strength. Most site failures come from poor beam detailing, wrong stirrup spacing, bad anchorage, or insufficient cover. C. Columns. The strength columns live or die by columns are compression members. A weak column, guaranteed structural collapse. Key points. Axial load plus bending, almost always combined. Long columns buckling risk. Ties spirals prevent sudden shear failure. Real-world truth, earthquake failures. Most start with poorly reinforced or overloaded columns, not slabs. D. Footings, the hidden heroes. Footings transfer building loads to soil. Key points. Isolated footing, combined footing, raft mat foundation. Soil-bearing capacity decides footing size, not gut feeling or builder experience. Weak foundation equals everything above is useless. 3. How these elements work together. Think of it like this. Slabs spread the load. Beams carry the load. Columns channel the load. Footings deliver the load safely to the ground. If even one of these four misbehaves, the entire system is compromised. 4. Why every civil engineering student must master RCC, because RCC design appears everywhere. University exams, competitive exams, job interviews, site work, government projects, consulting offices. And it's the highest view topic across all civil engineering channels. RCC equals guaranteed learning. 5. Why this topic matters for the future. RCC design is becoming smarter. AI predicts crack patterns. Machine learning optimizes steel quantity. Parametric tools auto-scale reinforcement layouts. Smart sensors monitor structural health. But the fundamentals, slabs, beams, columns, footings, will remain unchanged for the next 100 years. You master these, you're already ahead. That's your crash course into what RCC really is. In the next lectures, we'll break each component down with clarity and simplicity, the way civil engineering should be taught.